Okay, ma'am. Video stream live है. You can start.
Okay, so we will discuss the design of YouTube today. Uh, like we already know, कि YouTube is for streaming videos, uploading videos, watching videos, and इसके अलावा what else we can do? We can like the videos, we can comment on videos, we can save the videos and watch list and those kind of things. So, before we dive into the design scope, like let's just look at some of the facts of the YouTube. These are from 2020. So, in 2020, the total number of monthly active users on YouTube were 2 billion. This is the monthly active users, and the number of videos watched by the users on per day was 5 billion. I think these days it might be even larger or maybe smaller, because I think these days people are also using Instagram or uh, TikTok, etc. So maybe traffic might have reduced on YouTube, but I'm not sure about that. And 73% of US adults were using YouTube. There were 50 million creators in 2020 on YouTube. Like from here, you can see that the user base was quite big. So definitely, this was something that was a scalable system, a large system. So, and it's also available in 80 different languages. So, looking at this, that we know that these video platforms, we are not only thinking about designing YouTube. We can say in like we want to design a video sharing platform. It might be Netflix, Hulu, or TikTok, anything where we can share the videos, right? So how we can design such a system? First, we do need to, because we know that we have a lot of things. We have a lot of features on YouTube available. Definitely, we cannot design every single thing in a 45 to 60 minutes interview. So we need to establish the design scope. So for this, we just first step is always that we discuss the requirements with the interviewer, and then we agree on the scope. So we can ask like what features might be important. For now, we can assume that we only need to upload the video and watch a video. We do not care about anything else. Like we do not need to look at the design for likes, comments, or other things. We are only thinking about the video upload and watching the videos. And we are also looking at which clients we need to support. We want to support mobile apps, web browsers, smart TV. How many users we have? We can assume we have 5 million daily active users, and daily time spent on the product. We can assume it's 30 minutes. And we also support large percentage of international users. And yeah, for video resolutions, we need to support multiple video resolutions and formats. These can be like 360p, 480, 720, 1080 formats. Like these can be in like MP4 or some other formats. Do we want to encrypt our videos? Yes. File size requirements for videos, we can say that the maximum allowed video size a user can upload is 1 GB, not more than that. And the next thing that we can discuss, if we can use an existing cloud infrastructure. So we can assume that we can use the blob storage for storing the videos, because in actual system design interviews you do not need to design everything from scratch, right? So you cannot say that I will design my own blob storage from scratch, because if you have something that is already available, if an infrastructure is already available, you can reuse that. You can discuss this with your interviewer if I can use an existing infrastructure. So mostly whenever you are designing something, even Netflix is using the infrastructure by Amazon or Google. They did not implement everything from scratch. They did not implement their own blob storage from scratch, because if something is already present there, then we should definitely use that instead of rebuilding or reinventing the wheel. So yeah, we can use uh, some of the infrastructure by Amazon, Google, or Microsoft. Okay, so we have discussed some of the requirements and design scope. Now we want to look at some of more of the requirements. So we want to have the ability to upload the videos uh, as quickly as possible, and we want smooth video streaming. We also want we also want the user to provide the like we not exactly user, but need to be able to change video quality based on the network speed. We also want the infrastructure because we are using the infrastructure provided by these companies. So we want to make sure that we use low infrastructure cost because we do not want to implement something that is very, very costly. So when you're actually implementing, like whenever you are designing, making system design decisions, you actually also you do not only look at some of the latency requirements, performance, and those kind of things. You also are considering the cost as well. Like if you join any company, big company where you have to implement, or even a mid-level company, cost is the very important factor in your design. So we need to make sure that our infrastructure cost is small, and we have high availability, scalability, and reliability. And we know that we want to support mobile apps, web browser, and smart TV. Before diving into the high level, we want to do some of the back of the envelope estimation to like look at the storage requirements and how many users will be using our app daily. So first thing is that we discussed this previously that we have 5 million daily active users, and let's assume that users watch 5 videos per day. Like one user watches 5 videos per day on average, and there are 10% of the users who upload one video per day. Like out of 5 million users, 10% of the users will upload one video per day. So, and we'll assume that the average video size is 300 MB. Then in this, based on this data, we can compute the total daily storage space. So we know that we have 5 million daily active users, and 10% of those users are uploading the one video per day. So which means 10% of 5 million, we need to find the 10% of those 5 million users and then multiply that with 300 MB, because those many users means and one video is associated with one user, so which means we'll have 10% of 5 million videos, which will have, and then we will multiply this with 300 MB and we will get 150 terabytes of storage. So this is the storage that we will need on daily basis. Like per day storage, we will need 150 terabytes of storage. Next thing, we need to discuss the CDN cost, because the thing is that the video streaming, you have to perform this from content delivery network. Content delivery network, we already discussed in some previous sessions that these are the servers where we can place the static content that can be served from the near locations from the users. So if your clients are in Ohio, let's suppose, then those clients will be served from the CDN that is near Ohio instead of from a CDN that is in a different state. So, uh, definitely these CDNs are actually provided by the third parties. So let's suppose we are using the content delivery network of Amazon. So, and there is a cost associated with, and these are actually expensive. Like CDNs are expensive, although they provide low latency, but they are expensive. So we need to make sure that our CDN cost is minimal. So if you look at an example of Amazon CDN CloudFront, so if you assume that 100% of traffic is from the United States, then the charge from the United States is like $0.02 per GB. Average cost is $0.02 per GB. So which means if you have 5 million, if you want to calculate the cost based on this assumption, then you have like 5 million users, and each user is watching 5 videos per day. Like you have 5 million users per day, and each user is watching 5 videos per day, and the size of the video is average size of the video is 300 MB, which is like 0.3 GB. And the cost of, so we find out like this is the total storage that we need, and per GB cost is $0.02, so we multiply that with $0.02, so this will give us $150,000 per day. So this will be the cost that we will incur with CDN for these many videos. So we will discuss, like, this is also a very large cost, so we will discuss this in the optimization section, like how we can reduce these CDN costs. if you look at this this table, you can see that per month cost for it depends on depends on the country. So like in South Korea, Kenya, it's I think more, yeah. In South Korea, Kenya, Middle East, South Africa, the cost is much not much larger, but a bit larger than the cost in US and Europe. So based on this, we can decide like where we want to host our CDNs and like how much storage it also depends on the storage. So if it's first 10 terabytes, then it's less amount. And when it starts like storage increases, then you will see that the cost also increases, or maybe actually decreases. So yeah, it actually decreases with larger storage. The cost decreases because if you are using more storage, then you will have to pay less amount. Okay, now looking at the high level design of this. So we will assume that because we are allowed to use the existing infrastructure of Amazon, Microsoft, or Google. We do not need to use do not need to build everything from scratch. So we can say that we can use blob storage for storing our videos. So we can say that we can use the blob storage, or we can use CDN, for example, Amazon CloudFront, for storing the for streaming the videos from the nearest locations. So looking at the high level system, we can say that we need CDN. We need the CDN for video streaming. Like when users are watching the videos, these will be served from the CDN, and everything else that is related to maybe user video uploading, or video transcoding, or user sign up, login, or those kind of things. Everything else will be handled by the API servers, but the video streaming will be handled through the content delivery network. And so when you will press play, your video will be streamed directly from CDN, and API servers will be used for something like feed recommendation, generating video uploads, URLs, metadata, cache, etc., user sign up, etc. Now there are two things that we want to definitely we do not have the time to discuss everything in a system design interview. So we can say that for now we want to look at two because this is what we discussed in the requirements. Like we want the user to be able to upload the video and watch the video, which means we need two features, like two flows. One is how we can upload the videos and how we can stream the videos when users are watching or click play to watch the videos. So we need two things, like video uploading flow and video streaming flow. So looking at the high level design of video uploading flow. So let's look at this thing. Like we know that we have some users and we have like our system is able to support like browsers, mobile devices, and other devices. So and we are using the blob storage as the original storage where our videos will be stored, and we have API servers which will be handled for other tasks, video recommendations, metadata, and all those kind of things, storing metadata. We'll have transcoding servers. These transcoding servers will be used for like because we know that our system, like जो हमारा system है, like it doesn't it's not necessary के because we can have different browsers can support different video formats, different devices can support different video formats. So we need to make sure that our design is able to convert a video into multiple formats so that it can be compatible with different browsers, different devices, and even like different video qualities. So for that purpose, we need the transcoding server so that we can convert our video into different formats. And then those different format videos will be stored in the transcoded storage. So this original storage will have just the video that the user uploaded, and then this will be converted into different formats. So we might have one video with 360p quality, one video with so here we had only one video, but then using the transcoding servers, we converted different. We created copies with different formats of that video. Probably one with 720p quality, or one with different format, maybe one with MV, HVI something, one is MP4 and those kind of things. So we just use the transcoding servers for those formats. Once the and then we use the completion queues. I will just discuss how this overall flow works, but first let's just discuss what are these components in our video uploading flow. We already discussed the content delivery network. This is to store the, so once we have transcoded the videos, these will be stored in the CDN, and then when user will click the play button to watch the videos, these will be streamed from CDN. And completion queue, these are the messaging queues that will be needed for when the transcoding process will be completed. Then these workers, completion handlers will update the metadata in the DB and metadata cache. This metadata DB will actually be storing just some of the metadata related to videos. For example, the format of the video, the length of the video, or the size of the video, these kind of things. These will be stored in this metadata, or maybe the user created the video, all those kind of things will be stored in this metadata DB. Okay, so now we know the basic building blocks, what these building blocks will do. We can just look how this flow will work. So initially user uploads a video to the on YouTube. So what happens, like, first thing is that this video is stored in the original blob storage, like we are using maybe Amazon blob storage, so it is stored there. Once it is stored there, and then on the second step, these transcoding servers will fetch the video from the original blob storage, and then these will convert different copies of the videos in different formats. So here we will have two things that will be running in parallel. So once the video is like transcoding server has converted the video in different formats. So if these two processes are running in parallel. So one thing is, like, once the video is completed, it will be stored in the transcoded storage, and then it will be stored from transcoded storage to the content delivery network. So this transcoded storage might be in a different in location, maybe in US, but definitely you do not have the users. We already discussed that a large proportion of users are the international users. So someone who is watching videos from Pakistan, then we cannot definitely serve this video directly from transcoded storage, or the CDN of some other country, maybe CDN of US. You will have different CDN servers definitely at different locations, maybe different CDN servers within the US, different CDN servers within Pakistan based on the region, maybe based on the province. So this video will actually be stored on this CDN storage. And now whenever a user who is from Pakistan will be streaming the videos from the nearest CDN location, nearest edge server, right? Edge servers are, like, we call those edge servers that are near the user's location. And someone who is watching from US will be able to stream the video from the CDN within US. So this is what will happen with once the video is being converted into different formats. And definitely all of the formats will be stored in the CDN with different qualities, different formats. All of those videos will be stored in CDN. And the second thing that is running in parallel is, like, once the transcoding is completed, then this will send an event message to the messaging queue that transcoding is completed. Now we need to update the metadata for that video. So what happens is, like, here we have some workers. These workers will like, maybe are the scheduled jobs, or these can be triggered when a new message arrives in the messaging queue. So what happens that these workers will these workers now know that the transcoding is completed, so these will now update the metadata DB and metadata cache and store the results, store the metadata of the video within this. So in this case, like when transcoding is completed, so let's suppose the transcoder created one video with the format with MP4 format and 360p quality. So this, once the transcoding is completed, this completion handler will store the size of the video, the quality of the video, the format of the video as a metadata in this metadata DB and metadata cache. And if there is another video that is also completed, like 460p quality, that is also stored here, 720p quality that also comes in messaging queue, and that is also stored. So this is how all of this data is stored here. And this is what happens with the once the video transcoding completes. Another flow that is also being done in parallel is like when the user uploads the video here. So there is some metadata that can be stored before we can convert that past this to the transcoding server. So these two things can also be done in parallel. Like here, the user uploads the video, user is being sent here for uploading. While this is being uploaded, so this can be the metadata related to that video can be stored here, like maybe URL, the user who created the video, the actual quality that user created the video with, and description and all those kind of things will be stored here. Will also be like for this, like we will that request to update the metadata when user started uploading the video, that will go through load balancer, and then load balancer will call the API servers. So these API servers will then upload the metadata for that video in metadata cache and metadata DB. Here we definitely need load balancer because we already saw that there are 50 million creators. So if we have like maybe 1 million users who are uploading the video every day, maybe, then definitely we need a scalable system that can distribute the traffic among multiple servers. So we need the load balancer here. Okay, so this is how our uploading the video, high level design of the video uploading will look like. Any questions so far? All right. Next thing is we already discussed like how the metadata will be updated when user first starts uploading the video. And next we look at the video streaming flow. So whenever you will start watching the video on YouTube, it will start immediately. Like, so when you start watching the video on YouTube, what happens is like you do not need to download the whole video to start watching it. Like when you are watching it online, then you can, as quickly as you click the play button, it starts streaming. So that is called the video streaming. And online video streaming, like so what happens is like instead of so what video streaming what happens behind the scenes for video streaming is that the whole video is not being downloaded. The small chunks of the videos will be downloaded that can be watched continuously. So when users start the click the video, there is some buffer that you can see, which so whenever there is this buffering, which means that some of the part of the video that needs to be played is being processed or is being downloaded. So it means like if you have like 5 minutes video and you started watching it, then some small chunks of the video, maybe 5 seconds of the video, the frames for 5 seconds are being downloaded, and then these are then the user can watch the video. So while user is watching these 5 seconds video, the next parallel process might be downloading the next 5 seconds, so that once these are done, these are already available. While user is watching these 5 seconds part of video, the next one are being processed and being downloaded, so that user can then watch. When user moves to these next 5 seconds, these can be streamed. So this is how the video streaming process works. And so there are different streaming protocols that are used for the streaming. We do not maybe need to go through these because these are some complex topics. We do not need to worry about these. Some of these are MPEG, Dash, Apple HLS, Microsoft Smooth Streaming, and Adobe HTTP Dynamic Streaming. We do not need to worry about this, but these are some of the streaming protocols that are being used for video streaming. And when we are designing our video streaming platform, then we need to be able to discuss the trade-off, like which streaming protocol we will be using. So, but definitely this requires some domain knowledge. We do not have like the time to discuss like how exactly the streaming protocol works, because that will take a lot of time to discuss. So the thing is that we need to choose the right streaming protocol to support our use case. How the high level design of the streaming process will look like is kind of very simple, because you have already stored your videos in the content delivery network, which means that you can stream the videos when client or user clicks play on the browser or any of their device, then that will be the video will be streamed from CDN. So this is how the high level design of video uploading and video streaming flow would look like. Now we can go into the design deep dive. So first thing is video transcoding. Like we discussed this in the high level design of video uploading flow, that we have transcoding servers that will transcode the videos into multiple formats. So how exactly this will work? So let's just look at this component. So so the thing is, when you first record the video that you need to upload, then your device can give it some certain format, and different devices can give your video a different, can like record the video in different formats, right? And different cameras can record the videos in different formats. So you have to like now play this video on multiple different devices, right? So this needs to be encoded into multiple bit rates and formats. So this is what our transcoder does. It converts your video into compatible bit rates and formats. What is the bit rate? It is just the rate at which the bits are processed over time. Which means if you have a higher bit rate, your video quality will be higher. So we want to have different versions of videos with different bit rates, so that the users who want high quality videos, they can see high quality videos, and the users who are on the high latency network, they can probably move to the low quality videos. So why do we need this transcoding? Is like, we already know that this is the one thing that we need. We need compatible bit rates and formats. Other reasons to transcode the videos is that we know that raw videos will consume a large amounts of storage space. So we want if you look at an example of high definition video that is recorded at 60 frames per second, then it can take 100 GB of space. So to optimize the space, we need to transcode the videos, and we need multiple devices and browser to support different types of video formats, because all devices cannot support all types of video formats. So, and we know that different cameras or different devices can record the video in a specific format. That specific format might not be compatible with the different device. So that's why we need to convert the videos so that these can be compatible with multiple devices and browsers, can be supported with multiple devices and browsers. And also we want to make sure that users who want to watch high quality videos we can deliver them the high resolution videos. So we can convert our videos into different resolutions like 360, 720, 1080, etc., or 4K. And we also need to transcode into different qualities, so that because whenever you're watching video on YouTube or any other streaming platform, what happens is when your network is fast, your video is like running on a high quality one. But if your network becomes slow, you can see that your video is automatically switched to a low quality video. So it automatically probably switches from 720 to 360p. So for that purpose, we also need to convert our video into multiple video quality, so that if network conditions change, we can like switch to like the our application can automatically switch to low quality video. Uh, okay. One more thing is like we can have like for like we know that many types of encoding formats are available. So we need two things. What is the one is the container. So this container can have like the video file, audio, and the metadata. Metadata can be like the file extensions, for example, the format of the, like it can be AVI, MOV, or MP4 file. Uh, Similarly, codecs are the like containers store this kind of information, your video file, the audio, and the metadata. And codecs store the algorithms for compression and decompression. So this is for like reducing the video size, because we saw that raw videos can consume a lot of space. So we want to have we want to have some compression algorithms that can reduce the video size but still preserve the video quality. So so these codecs can be like, we can use different codecs, H264, VP9. We don't need to worry about what these things, but these are some codecs that we can use for compressing the videos into uh, smaller sizes but preserving the video quality. It's not like we do not want that. If we are compressing the video, like if we are compressing a 720p quality video, then we want to keep the quality to 720p but use lesser space compared to raw space that we were using previously. Uh, okay, next thing is like how the this video transcoder works. So like there is something called the directed acyclic graph. This is just this is something that can help you to execute your tasks like in parallel or in sequential. So if you look at this example, so this is just a directed acyclic graph where you have an original video and you have three tasks to perform. Like you have the video you have the video for the video, audio, and the metadata. You have three things for that video. So what you can do with the DAGs, that you can perform these sorry. Okay, so what we can do is like we know that we have three tasks here, like video, audio, and metadata. So we can perform these tasks parallelly. For video, we can perform the tasks in parallel. For audio, we can perform audio encoding in parallel. For metadata, we do not need to do anything for metadata, but for video and audio parts of the video, we can perform these tasks in parallel. So we use the DAGs for this purpose. And like so if you look at the video, even for video part, you can perform all of these tasks in parallel. You can do the inspection, video transcoding. You do not need to wait that once the inspection is completed, then I will do the video transcoding, or once the video transcoding is complete, then I will go to thumbnail and those kind of things. So with this, you can say, okay, I can perform inspection, video transcoding, thumbnail, watermark, everything in parallel. So you can perform all of these tasks in parallel. And once all of these things are done, then you can assemble all of these things into one video. So all right, so let's just look at what the inspection does. The inspection part of the video, what it does, like it just makes sure that the video had good quality and these are not malformed before we can convert these into different formats. Then we have video encodings. These will here what we do, this task will convert your video into different resolutions, codecs, bit rates, etc. So let's just look at one of the example of video encoding. So what is like, you can see that we have multiple tasks within a task. So that is why it's called the directed acyclic graph, because you are starting from this original video and then you have this video task. Then within video task, you have multiple tasks, inspection, video encoding. Then within video encoding, you have multiple tasks, right? You are saying that within video encoding, I am converting it into different formats or different qualities and those kind of things. So, so here you can see that for video encodings, you are saying that I am going to convert my video into, these are my codecs, MP4, and we can also have AVI or other formats. So we say that we have these video qualities 360p, 480p for MP4, 720 MP4. Similarly, we can have 360p AVI, 480p AVI, and all those kind of things. So this is what the video encodings is doing, and this can also be done in parallel as well, because you do not need to wait, because these are independent. You do not need to wait once the video is converted. Once I get the video in 360p quality, then I will move and go convert it into 480p. Once I am done with 480p, then I will move to 720p. You do not need to worry about that. You can perform all of these tasks in parallel. Okay, next thing is the thumbnail. So thumbnails are these can be either uploaded by the user, or these can be automatically generated by the system. There can be other tasks as well. Then there is some watermark, which is just the image that is overlay on top of your video to avoid copyright issues. So and then we have so how exactly your video transcoding looks like. So we just looked at the video transcoding can involve a lot of tasks that can be done in parallel. Or next thing is how exactly our overall transcoding video architecture will look like. Can have different parts here. We have the preprocessor, we have DAG scheduler, we have resource manager, task workers, encoded video. Um, like so Upper here we just discussed about the DAG, like we can have multiple tasks running in parallel, but how exactly the flow of the video encoding will work, this is what we will discuss here in the video transcoding architecture. So we have this preprocessor. What the preprocessor does, it will split your video into a smaller group of pictures, right? So because why you need preprocessor? With preprocessor, again, because the videos can be very large and you want to do this in distributed fashion, you want to perform the tasks in parallel. So what you can do is preprocessor. So once the user uploads the video in the original blob storage, so this preprocessor will just split the video into small chunks. So if the video was 1 hour long, then it can say, okay, I can split it into 5 minutes with 5 minutes videos. So these are 5 minutes videos, and then each of this chunk can be processed individually in parallel. Then I can process all of these chunks in parallel. And once I am done with processing all of these chunks, then I can assemble these at the end using the assembler. You might be thinking about how will I keep track of the order, because it might be possible that this 5 minutes chunk video, this was the first part of the 1 hour video. This was the second 5 minutes of the 1 hour video, third 5 minutes of the 1 hour video. How will you make sure that this part doesn't, in the assembled video, this part doesn't get here or this part doesn't get here? We need to have this in the correct order. So this assembler will make sure, and we will have this information already, maybe using the timestamps, we will know that this is the first part of the chunk and second part and so on, how we need to assemble. So this is what will be done by the assembler. Okay, so we know that preprocessor will split the videos into smaller group of pictures, and then but there is some old devices might not be supporting video splitting, but for now we assume that our system is able to support the video splitting, and then we will have this DAG generation, the directed data cyclic graph. We need to know what exactly we need to do. So this can be generated using the tasks that we need to perform. So looking at this configuration file, we know that we have we have two tasks. One is the download, and the other is the transcode. First we need to download the video, then we need to transcode the video, and those kind of things. Or and we can also have some within the transcode. So here we know that this is the first task. So what this directly acyclic graph is telling you, this is the first task. First task is to download the video. Once the video is downloaded, the next task will be to transcode the video, right? So so this is your first task, so which means that transcode is dependent on the downloading task. So we cannot perform the transcoding before we download the video. So we need to wait for the video to be downloaded before transcoding can be performed. So, and again, here you can have another, because you know that this is another task transcode, so you need to define that task as well in your configuration file. So you say, okay, this is my transcode task, and this will be the output of the transcode task. Here we haven't added anything. We can, if we need to add something else, like another task that might be needed to perform after the transcoding process, then we can add the next task here, and then we can define that task as separate task within that one. So this is how the configuration files are. These configuration files might be defined by the client programs, and then based on these configuration files, we generate the tags. So for this example, we only have 2 tasks. So this is how the tag will look like. We know that we have to first download the video, then we need to transcode the video. Okay. So next thing is to cache the data. So the preprocessor will cache these segmented videos, and we also store the metadata in the temporary storage. So what happens is, let's suppose if you did the pre-processing, right? If you perform the pre-processing, you have already cached the data. If you didn't cache the data in pre-processing phase, then you probably need to perform the splitting again. So this helps in this caching those splitted videos, helps you to avoid the failure issues. So if, for example, for any reason you're encoding phase, then you can perform retry operations on this persisted data, because you already splitted the data using the preprocessor. You do not need to redo that again. It's already available in the cache and it's already persisted, so you can perform the encoding again with retry operations. And it is also possible that on few chunks of the data, the encoding worked well, but on future, like probably on this chunk it worked fine, on this chunk it worked fine, but this chunk failed with encoding. So since this is already available in the cache, we do not need to extract it again from the preprocessor. So we will directly pick this chunk of the video, and then we will perform the encoding again. We can perform the retry on this again. For now, let's just, I think we can just end the discussion here. We can discuss the rest of this design in the tomorrow session. Any questions?